Hello everybody, today I want to talk about section 3.4. So I went to Canvas and like you see you have a PowerPoint with section 3.4. I'm not going to record new videos about section 3.4 because technically I want to open that PowerPoint and talk about the most important informations which you guys need from this section. That's fine. Okay, so just give me a second. To set up. Okay, how I can change that? Okay, since view slide only. Slide play. Okay, so that's much better. So in 3.4 we'll briefly talk about the graphs of function which you guys need to know and piecewise defined function. So let's start, and we talked about this a little bit before. Let's start with the function. So let's talk about the function square root of x. This is square root function. So you're responsible of knowing how to find the domain of this function. So you have square roots. So technically when you have a square root, all the values, all the expression, all the values under square root, they have to be 0 or greater than 0. So the domain and the range of this function, which below you see how the graph of the function looks like, are all real numbers, non-negative, which means the domain will be all the x's greater or equal to 0, and the range, which is your y values, also will be all the y values which are greater or equal to 0. So like you see, the graph of square root of x you only have in quadrant 1, so there is no negative x and there is no negative y values. X and y intercept of square root of x function, like you see, it's the point 0, 0. So origin is the x and the y intercept. The function is neither even or odd. Even function, we talk about it, even functions are the function which are symmetric with respect to the y-axis. We have nothing on the left side of the y-axis right here, so the graph can be even. And odd functions, that's the function which have symmetry with respect to the origin. So I mentioned in the class that the graph has to be like diagonal a little bit since the graph is only in quadrant 1. So this function, it's neither. The function's only increasing. We don't have for all x values, when the x increasing, the y values also will be increasing. The function has absolute minimum, so the lower point on the graph is the origin. So when x is equal to 0, the absolute minimum will be 0. Very important, the absolute minimum of square root of x, it's not local minimum. Just going back to local minimum and local maximums, again, to have local, the graph has to change in behavior, has to change from increasing to decreasing or decreasing to increasing. In this case, since entire graph is increasing, we don't have any local minimum and any local maximums. However, we have absolute minimum because we can easily find the lower point on the graph, and there is no absolute maximum. Like you see, the graph continues growing and increasing to positive infinity, so we cannot find the highest point of the graph. Okay, I will go to the next slide. Hold on a few seconds. Play. Okay, let's go to the next one. Next function which you need to know, it's a cube root function. So cube root function behaves a little different. You will need to decide if cube root of x is even, odd, or neither. and you have to state it. So we'll talk about that example if the graph is symmetric with respect to the y-axis or symmetric with respect to the origin. So that's how we're going to know function is even or odd. Also, we'll talk about the intercepts if we have any, and graph it. Okay. So let's talk about it. So technically, to check if graph is even, so what we need to do, we need to replace x with negative x. So you're going to substitute x from original function with negative x. Cube root of negative x, this is something what can be evaluated. This is the same as negative cube root of x, which means we have -1 times original equation. So going back to the definition of odd and even, this is odd. When f of negative x is equal the same as -1 times f of x, that function is odd. What that means that your graph will be symmetric with respect to the origin, which we'll see in a second. Now, to find the y-intercept, we're going to replace x with 0. So you're going to plug in 0, where you used to have x, and cube root of 0 is just 0. What that means, so the y-intercept is at the point 0, 0, which the y-intercepts and the x-intercepts will be the same, and that will be at the origin. And on the next slide, I'm going to show you how the graph looks like. Again, on the test, I'm not going to ask you to create a table of values. Technically, what you need to know how the shape of the graph looks like. Okay. Right now, when you see the graph, you can easily see that the cube root function, it's the odd function. We see that origin symmetry. We find x and y intercept algebraically. Knowing the graph, you see that that's the origin. Okay. Okay, and that's the most important information about cube root of x function. And the domain, which are your x values. Let me just go back to the graph. So you guys can see it, that domain are all real numbers, and the range, which are the y values, are also all real numbers. The function is odd, the graph is symmetric with respect to the origin, and the function is increasing from -infinity to infinity, which means an entire domain. The function does not have any local minimum and any local maximum because the function is increasing an entire domain. Also, the function, let's go back to the graph. Sorry, guys. The function doesn't have absolute minimum and does not have absolute maximum because you cannot find the lowest point of the graph and you cannot find the highest point of the graph. Okay, next one, you guys need to know how the absolute value of x graph looks like. So I quickly going to show you how the graph looks like. Is that just your symmetric letter V? Try to memorize how the absolute value of x graph looks like. Knowing the graph, you can easily see that the graph is symmetric with respect to the y-axis, which means this function is even. We can see easily what is the x and y intercept of this graph, which is the origin. Also, here, knowing the graphs, you see that the function decrease for x values from -infinity to 0, and then function increase for all the x values from 0 to +infinity. So absolute value function change behavior from decreasing to increasing. What that means that you're going to have a local minimum at the origin at point 0, 0. Okay, there's no local maximum, and there's also no absolute maximum, since we cannot find the highest point of this graph. Local minimum in this graph is also your absolute minimum. And everything what I just mentioned here, you guys have all this summary on the PowerPoint. The domain, which is all the x values, knowing the graph, you guys see that's all real numbers. However, range, which are your y values, are all the y values greater or equal to 0. Okay, function is even, since it's symmetric with respect to the y-axis. Function is in decreasing for x values from negative infinity to 0, and of course function is increasing from 0 to infinity. Reviewing, again, for increasing, decreasing, like you see, you always keep your open interval. Function has absolute minimum, which is also local minimum at x equals 0. Okay, constant function f of x equal b. This is your horizontal line, y equal 5, it's a constant function, y equal 2, it's a constant function. Again, horizontal line, you have one y-intercept, in this case at point 0, comma b. If your constant function has equation y equal 5, your y-intercept will be point 0, comma 5, okay? So that's the constant function. You need to know identity function, which is y equal x. It's a straight line which goes through the origin. You need to know how the graph y equal x squared looks like, which is the basic graph of quadratic function. Parabola, origin at the point 0, comma 0, and definitely y equal x squared. It's even function because you should notice that we have that y-axis symmetry. The domain will be all real number. Range will be from 0 to positive infinity, including, of course, 0. It's decreasing for all the x values from negative infinity to 0, and then increasing from 0 to positive infinity. That's why the origin point 0, comma 0, it's our local minimum and also absolute minimum. No absolute maximum and no local maximum in this graph. Y equal x to the third power. Okay. Again, this graph, just knowing how the graph looks like, you should see that the domain, which is your x values, all real numbers, range, all real numbers, no restrictions. The graph is symmetric with respect to the origin, so the graph will be at. No absolute minimum, no absolute maximum, since we cannot physically tell exactly what is the lowest point of this graph and what is the highest point of the graph. And the graph is increasing in entire domain, so we don't have any local minimum or maximum. This is cube function. Cube function is increasing. It may not look like, but however, yes, you have increasing function. Talk about square root of x, cube root of x, 1 over x, that's the reciprocal function. Again, this is very interesting function because you have a huge gap. This function is symmetric with respect to the origin. So your graph is in quadrant 1 and quadrant 3. It's definitely odd because of that origin symmetry. Domain, which is the x values, all real numbers except 0. And the range, which is the y values, also it's going to be all real numbers except 0. Okay. Okay. Greatest integer function. I will explain that function. I'm going to have a very specific video about that function. This one it's a little tricky. The PowerPoint show you the greatest integer function. Again, I will go back to that. Pay attention on Canvas. You're going to have the lecture about greatest integer function. And piecewise defined function, also I going again here on the PowerPoint, you see the detailed example which has all the solutions. I'm not going to talk about this one at this moment because I want to record the lecture and slowly go over the piecewise defined function, which technically we put in 2 or 3 functions together, and each piece of the function has very own restricted domain. So I will talk about this function in the video together with step function. Okay, so that's it for now. Again, please pay attention to chapter 3.4, which you are responsible of knowing how those major function in the graph looks like. And again, on top of that, I'm going to do the YouTube video about those 2 functions, piecewise defined function and step function, which looks like the steps. Okay, thank you so much for watching, and if you have any questions, like always, send me an email. If you need any help with homework, or if you struggle with the material, let me know what you struggle. We can set up the video phone call, or any different type of conference using online resources. Thank you.